Welcome to Excel 2013 statistical video number 16. Hey, if you want to download this workbook and follow along, click on the link below the video. Hey, we're in Chapter 3. We're still doing descriptive statistics. Back in Chapter 2, we did tabular and graphical. Hey, in this chapter, we're going to do numerical measures. That just means we're going to calculate a number, like the mean, which is an average, the median, the mode, standard deviation, and many more numerical measures. Now we're on the topic sheet. In this video, we're going to talk about averages. Mean, add them all up, divide by the count. Median, sort the list and find the one in the middle. And mode, the one that occurs most frequently. All of these are types of averages. We calculate so we get a typical value, one value that can represent all of the data points. This is a measure of location. For averaging, we're calculating a measure of central location. Later videos in this chapter and throughout our class, we'll talk about locations, things like percentile, are you above the 75th percentile, z-scores, and many more. Now, we're going to start by going to the sheet location. What is location? It's a way of locating a particular value in relation to a data set. So here's you. You got 79. You might want to know something like, are you above average? Which means, are you above a typical value? Or you might want to know something like, are you above the 75th percentile? In both cases, we have a number, and we want to locate it in relation to a data set. So let's calculate the mean, so we can answer the question, are you above average? Hey, we're going to use the average function, AVER. And from our dropdown, we see it's in blue, so I hit Tab. Now, average will add them all up using sum, and then count how many they are, use that as the denominator, and calculate the average. I'm going to highlight this. The average function will do the heavy lifting. When I hit Enter, boom, 67.7. That is our typical value, our one value that stands in and represents all the data points. It is a measure of central location. This is kind of in the middle, a kind of a typical value. So are you above a typical value or above average? Yes, you are. Now, what about answering the question, are you above the 75th percentile? Well, percentile is a marker. It's going to actually have a point, either a value or in between a value, that can split a data set according to whatever percentage you give it. So if I say percentile 75th, I want the actual number that splits the set. So let's just say it's 78. That means 75% of the values are below that marker and 25% are above. So percentile is a very specific marker. Here it is. And we'll talk more specifically about this calculation and how this function does it in a later video. But right now, I'm just going to highlight all of the values. And the K, that's the percentile as a percentage. 75%, percentile.exe will spit out the actual number that is the marker. So that means if we had a marker, it's right in between 78 and 79. This number is not even the data set, but it exactly splits. 25% above, 75% below. So are you above the 75th percentile marker? Yes, you are. So in both cases, we were taking a number and locating it in relation to a data set. Now we want to go over and talk about terms. And we're going to remind ourselves from last chapter. Population, that's all of the elements of interest in a particular study. A sample is just a subset. Most of the time, we cannot get all of the items we need to do our calculation, so we have to base it on a sample. Inferential statistics, the process of using data obtained from a sample to make estimates and test hypotheses about characteristic attributes of the population. Hey, we're going to use mostly samples, of course, and so we need to know what sample statistic and population parameter. Anytime the measure, which is what we're doing in this chapter, calculating numbers, are computed from data from a sample, they're called sample statistics. When they're calculated from populations, they're called population parameters. Why is that important? Because in statistical inference, a sample statistic is referred to as the point estimator of the corresponding population parameter. Because remember, we usually can't go and calculate something from the population. So the sample statistic is going to be like pointing towards the population parameter. And throughout the class, we'll get a better and better understanding of how good our point estimator is. But that's the terminology. The sample statistic is our best estimate and is a point estimator of our population parameter. Now, let's go over and I want to talk about mean for a P or S. That means a population or a sample. This is our first measure, X bar. That's an X with a bar over it. It means from a sample, we're calculating the mean. X bar, that's how I'll write it in this class. That's how it's pronounced. When you see it written like this, math notation, you actually pronounce it X bar. I'll use both in this class, but I'll tend to write it out like this, X bar. It just means we're adding up all of the X's and dividing by the count. Now, if we're doing it from population, we're going to use different notation. That is a Greek letter called mu, just like a cat sound, mu. Here, well, it looks like it's exactly the same, but we're going to indicate that it's from the population by using capital N. Add up all of the particular X's and divide by the count. Little n for sample, big N for population. Hey, let's just check this out. We have X sub 1, X sub 2, X sub 3. So we have 15 from the population. Hey, this is going to be mu, and we can use our average. It'll do the heavy lifting. It'll add them all up and divide by the count. Control Enter. So the population mu is 1087. Now here's a sample. You can see I color coded it. I just took every other one. Let's calculate the sample here. X bar, this is going to be called equals average. Oh, we're using the same function for both. That won't always be the case. Sometimes, like for standard deviation, we'll have a different formula for sample than for the population. But for mean, they're both the same, average. $11. $11. Well, most of the time, our X bar will be pretty good point estimator of our population parameter. All right, let's go over and talk about mean. I'm going to go to the sheet mean. Now, this is a measure of location. It is an average, a typical value measure of central location. We want to think of typical values, though, as calculated so that we have one value that can represent all the data points. If you are talking about test scores, we want to calculate the average so we can communicate and talk and discuss with people. Hey, the average was 75. Other times, like if we have weights of a salad filling machine, so it's filling bags, plastic bags with salad, we want to have that mean so that we can gauge whether the machine is filling accurately. And we've mentioned that earlier in the class, and we'll get to in Chapter 10, see the techniques for that. But in both cases, we're going to be calculating mean. So I'm going to use equals average. And this is a population, so Control-Shift down arrow, and then I'm going to use Shift-Enter. That puts the formula in the cell and pushes it up. So 67.45. Now we have an average, which is our mean, and we can compare our score and see how well we did. Here, let's go ahead and use the average function to calculate X bar. Control-Shift down arrow, Shift-Enter. So 10.1845. So if the bag of lettuce is advertising that it has 10 ounces and you get 10.18, well, you're not going to be so mad. But if you were the manufacturer, we need to know, is the machine filling too much? We can use this average to help us estimate whether the machine is filling correctly. So 2 examples of mean. Now, we mentioned earlier in the video that we have different averages. Mean is just one. Well, why wouldn't we use the mean all the time? Why do we need median and mode? Well, mean is good for quantitative data when there are not extreme values. Extreme values can make the mean look too big or too small. We mentioned this in earlier videos, but if you have one value that's huge and all the rest are small, then that one value makes the mean look too big. If there's a small value, it might make the mean look too small. So in that case, the median will be more representative of a typical value. Now let's go over to the sheet median and talk about median. Now we have 2 examples, house prices and salaries at an accounting firm. Now, you'll probably have heard real estate people talk about median price. And the reason why is there might be a few $1 million houses or $2 million houses, and all the rest is in the $300,000 range. So the real estate person doesn't want to say the average is blah, blah, blah. They want to say the median, because the median will more fairly represent the data points, meaning the house prices. Now let's talk about median. Median is an average, a typical value measure of central location. Literally, it's going to divide. It is percentile 50% because it will divide the set exactly in half. It is the value in the middle. So literally, here's what you do for median. You would take the data set. You take the data set and sort. I'm going to right click, sort, and say sort A to Z. Now that worked perfectly because we have empty cells all the way around this proper data set. But now, once we have it sorted, we have to find the one in the middle. Well, I'm going to highlight all of them and look down at my status bar. I can see the numerical count of 20. That means, well, wait a second, that's an even number. If I highlight, and I'm looking down at my status bar, when I get exactly 10, well, that's halfway through, but there's no number in the middle. This isn't an odd number. I'm actually going to add some fill color so I can visually see that the set is divided in two. The one in the middle isn't there. So here's what you do. When you go to calculate the median, and we're going to use the median function in just a second, but the longhand way, if there's an even number of data points, you average the middle two. So I'm using the average function. I'm very carefully going to highlight number 10 and number 11. And then that is the median, 195,827. Now, we don't have to sort and then count how many to see if there's even and average. In a second, we'll see the odd. If there's an odd, you actually pick the one in the middle. You don't have to do that. We can simply use the median function. So median, it will look at all the data points and internally make all those calculations, sort, and it knows if it's an even or odd number. In this case, boom, it gives us exactly the correct number, 195,827. So the realtor now has a median value they can use to discuss the neighborhood. Now, here's what you probably don't want to do when there's extreme values. Remember, we're trying to find a typical value, one value that represents all the data points fairly that we can use in discussions and in other ways. So I'm going to highlight the data set. And, oh, the mean is 392,410. And why is the mean so much higher than the median? Well, when you have a data set, sometimes there's a few big values. And here we have a 2.5 and a $1.2 million houses. The rest of the numbers are far below that. So a few big values pull the mean up. That means that this average, the mean, doesn't represent all of its data points as fairly as the 195,827. So real estate people tend to use the median. Now let's look at a second example here. Here we have salaries at an accounting firm. I'm going to do the same thing. Right click, sort, highlight. I'm looking down in the status bar. Oh, there's 21, so there actually is one in the middle. I'll highlight exactly 10 and add some formatting. Highlight exactly 10 and add a different formatting. And there it is. That's the one in the middle. Now, notice over here we could say the marker, which was 195,827, it's in between these two values. So exactly 50% below, exactly 50% above. But over here, if we said that 50% below, 50% above, we'd be off just a little bit. Now, later when we talk about percentiles, we'll be very careful in our language. We'll say approximately, because when you're finding location with the median and later with the percentile, it's an approximation. So approximately 50% below, 50% above. Hey, but we found the one in the middle. And probably since we have one big, huge, or a couple big, huge accounting salaries here, An average would tend to be too high. The median, the actual one in the middle, is going to more fairly represent all of the data points. Let's calculate the mean. Equals AVER, and we'll highlight, Control-Shift-Down arrow, and Enter. So the average is 161,000 about, and the median, and we'll do it on our unsorted list, we could see it gives us exactly the same thing. So probably the median gives us a more representative, typical value. You know, if you were trying to get a job in this industry and they said the average was 161,000, and then you got out into that industry and realized that most of the salaries are not. There's just a few big ones that are pulling the mean up. So a median might be a better way to represent all of the data points. Now, we've talked about mean. That's good when there's not any extreme values. The median, that's great when there are some unusually small or big values. We need to talk about one other type of average. And we're going to go over here and click on the sheet mode. Now, what in the world do we do with nominal, or in this case, ordinal data? We cannot use the mean. So we can't use the median either. We need to use the mode. And all it does is it counts. It's still an average typical value, a measure of central location. Typical value. We're going to count each one of the different categories. For rating your professor, the one that occurs most frequently will be our mode. Now, mode, we can use MODE.SNGL if we have number data. We use COUNTIF or PivotTables if we have categorical data, nominal or ordinal. So we have ordinal here. I'm using COUNTIFs. I'm going to highlight the whole range, Control-Shift-Down arrow, F4 to lock it, comma, and then I'm going to get relative cell reference are bad. Control-Enter, and copy it down. The mode is the one that occurs most frequently. We want to use the mode when we have categorical data like this. Now, sometimes we use the mode on numbers or quantitative data, but most of the time we're using the mode when we have categorical data like this, because we really have no other way to calculate an average. We need the one that occurs most frequently. Now, let's come over here and talk about calculating the mode on quantitative or number data. Now, a lot of times, we're going to be doing the mode calculation in conjunction with the median and the mean. And we'll talk about that on our next tab here. But let's go ahead and look at the functions for mode. Now, it used to be we used the mode. That little yellow triangle means compatibility mode. In 2010, they totally changed all of the statistical functions, adding this dot convention. Now, some functions like MODE.SNGL and MODE, the old version, are exactly the same. Other functions for statistics got improved. But from 2010 and moving forward, we use the dot functions. Now, notice there's a mult, which means multiple modes. Single means it's only going to get one. Now, we simply highlight, Control-Shift-Down arrow, and Shift-Enter. So the mode, that means the one that occurs most frequently, is 68. The actual MODE.SNGL function will go and find the mode. It's saying the one that occurs most frequently is 68. Over here, we use COUNTIFs. We actually had to look over here and find the category. Bad was the one that occurred most frequently. Using COUNTIFs, we then looked over here and got it. The mode actually gets the value. Now, there's a problem with this. And let's go ahead and run a pivot table. And the only way you're really going to make sure if there's not multiple modes, that means more than one mode, is to either do COUNTIFs from a unique list of the numbers or use a pivot table. I'm going to go up to Insert, Pivot Table, or I'm going to use the keyboard Alt-N-V. And I'm going to put it on this sheet, low location. I'm going to put it right down here below, like in cell D44. Click OK. We're going to drag the one field down to rows. We get instantly a unique list of test scores. The same field down to values. It defaults to sum because it's a number. Right click, Summarize Values By, and we want to count. OK, so there's a bunch of ones. And sure enough, the MODE.SNGL pulled out the 68, but it totally missed the 76. When you have two modes, it's called bi-modal. Bi means two, so bi-modal. In other cases, you have multiple modes. This is multiple modes, but there's a specific name called bimodal. All right, so you got to be sure and do that because you never know. Now, there is the multiple function mode.mul. We're not going to do that in this class, but no problem. I have this great video and this link that shows you how to use it. There's also a formula that you can use to extract text values, and there's a video for that. I'm not going to do it in this class. All right, now here's some scores. Let's just go ahead and flat out. I'm not even going to bother with that mode.SNGL, although there's uses for it. Very important. I'm just going to run a pivot table. So Alt-N-V. Put it on existing worksheet, the location. I'm going to click I-21 and click OK. Horizontal scroll bar to scroll over. Drag scores down to rows, scores down to values. And here's our unique list. And oh, yeah, right click, summarize value by count. And here we have, see, there's lots of 4s. Oh, but there's one mode. So 5. Quiz score 7 occurred 5 times, so that means the mode is 7. Now I'm actually going to change the design, report layout, show in outline. So now we have our field name up there. And this one over here, I'm just going to put test scores. All right, so we have mode. The one that occurs most frequently. It's best for nominal and ordinal data, but we're oftentimes going to use it on quantitative data, numbers, and you got to watch out for bimodal and multimodal. Use that COUNTIFs or pivot tables to check. Now, one other thing, we want to go over to the sheet called skew and talk about the relationship between mean, median, and mode, and it has to do with skew. Now, later in a video in this chapter, we'll calculate skew. But we've already talked about skew, right? When we did histograms last chapter, chapter 2, we talked about skew to the left or negative. And we even talked about why, right? There's a few small values pulling the mean down. So the mean should be lower than the highest frequency, which would be the mode, right? Here for a bell shape, we're going to find that the mean, median, and mode are usually right in the center. And this is skewed to the right. There's a big value here pulling the mean up. But the highest frequency values, the modes, are down below. So let's go ahead, and we have our 3 little data sets here just with sample data. And we want to look at the relationship between mean, median, and mode. So I'm going to calculate mean. And these will be relative cell references. So when I highlight this, I'm just going to hit Enter. But notice I'm going to copy it over, and it will move to the next data set. Enter equals median, tab, and highlight. Enter, and then equals mode. Arrow, arrow, single. And then I'm going to highlight this data set and Enter. So now I can copy these over. We can check, and we see it got it right. The mean, it got it right. So let's just go up here. Remind ourselves of our histogram. Skew to the left or negative. The relationship between mean, median, and mode is going to be mean is the lowest because some small values are pulling it down. Then the median, then the mode. In most cases, this will be the relationship. Same with the bell, except for, whoa, they'll all be in the middle. They'll all tend to be pretty close or the same. And to the right or positive, if there's some big values, it's going to tend to pull the mean up, and the relationship will be mean the biggest, then median, then mode. Hey, all right, this video we talked about location, and we talked about mean, median, and mode. Next video, we'll talk about a specific mean called the weighted mean. All right, we'll see you next video.